Well, ladies and gentlemen, we'll take the balance this time for questions. I'll start by posing just a couple of questions to the group, but if you have them, please feel free to raise your hand and get involved in this dialogue. But I'm going to start with Jim. Jim, you're the group up here that's kind of the cutting edge of this because you're at the wellhead. They start corruption. Tell me how this change that we've been talking about has affected your business first, and then secondarily, where do you see the biggest opportunities going forward?
It's rather interesting. A lot of the issues that we never saw out of fracking in the older days was primarily, we believe now, is due to the fact that we're using fresh water 100% of the time. And then we went through this sort of gray zone during this ramp up right here, where there was not enough fresh water to use for fracking, and so they would use whatever was there or reuse whatever was there. And the price of gas was falling, so obviously you're going to go with the cheapest answer you can for a water source to frack with. What we're really seeing is two major shifts in the industry. One is that a clean brine, because most of the water that comes back is brine water, a clean brine water is actually better to frack a well with than fresh water, because it doesn't actually make the clays expand and explode. That's one, and that's not a total driver. The other big driver is that we have now proven that if they do frack with a clean water, and clean is defined as no suspended solids, bacteria, and heavy metals, they actually get a larger flow back. So when you were looking at the reservoir or the fracking field down below, when they're fracking that, they're creating a number of pores in the shale. So if your water that you're fracking with clogs those pores, the flow back becomes less because the gas doesn't have as many pores to go through as easily. So what we're now seeing is that this is probably one of the biggest drivers to use a water that does not have high suspended solids or bacteria or heavy metals for scaling, because it then doesn't impact the pore that the frac created. So we see a lot of positive things out of that.
Opportunities going forward, Jim? Where do you see it?
So the market is fascinating going forward. We've identified tight shale, tight condensate, and tight oil shale. So it's not just gas, it's oil, gas, and condensate all over the world. So we will be starting to ship units to Europe this summer, but we also see the same situation in Australia, where the technology will now open up the door for coal bed methane, which is probably creates the ugliest of all flowback waters. And what we're learning is how to not just break the emulsions that come back and oxidize it, we're now learning how to actually reduce the compounds that cause damage. So when most everyone talks about water treatment worldwide, they're always talking about oxidizing. Even if they don't use the word, that's what they're doing. Now we're starting to move into a world of reduction. And reduction becomes incredibly important as far as nitrates, selenium, cadmium in some of their forms, some of their valence forms. So what we're seeing, the learning experience we're seeing here that we've learned in the U.S., we see will translate across many countries. We have operations planned for Africa. We are also looking we are just now heading off to Oman in the same way. It might surprise you, but it builds in exactly what we're hearing is that there's a large, tight shale gas play in Saudi. And somebody would say, well, why would you want to start exploring for tight gas in Saudi when oil is so good and gas is so poor? Well, it's very simple. They need something to operate their rigs and their equipment. And by converting to a natural gas power source, they can operate their oil fields at a lower cost. And so there is a tendency in there that's very, very important that we're starting to develop.
Let me take that same question here and jump to the other end of the value chain. So you've got Jim up on the front end. Let's go to the back end now on the consumption side. Same issue.
Yeah, hopefully everyone's getting the picture that there's an awful lot of supply out there. And you need to look at where that supply can go. The opposite of supply is demand. So what are the demand sources for natural gas? And as the pie chart that you put up there a few moments ago depicted, there is residential use, which is the amount of new homes which are being built. And although there are always new homes being built, it's something that moves at a fairly predictable and relatively slow pace relative to the supply of natural gas. Now, the number of new homes that go in any given year is only going to be so much. And then there's industry, and that is basically the economy. Is what's the economy doing? How much natural gas does industry need? And especially during a recession, you're not going to see large growth in demand for natural gas there either. So transportation, and that's really where my company comes in. And we are, to the extent that we can, there's a real opportunity to get natural gas into the transportation sector as a vehicle fuel. And so what my company spends an awful lot of time doing is looking at the very best platforms to get to operate on natural gas as good or better than they operate on gasoline, and as many different platforms as we can. Our company in particular has made a lot of progress in a very short period of time with medium and light duty vehicles. That's been sort of the easier option, because the stations for natural gas, the infrastructure to get natural gas in a vehicle is relatively localized at the present time. Here in Seattle, you've got 6 or 7 retail stations where you can get natural gas. In a market like Chicago, you've only got 2 stations where you can get natural gas. So you're seeing that, you know, the vehicles that go the great distances between one major metro and another, those haven't been as easily accessible to get going on natural gas in the last few years. Now, that's really changing. You've got companies out there that are dedicated to bridging the gap between major metros with regard to natural gas fueling infrastructure. So that's doing wonderful things for the vehicles that we're looking at as far as demand items for natural gas. And so what you're starting to see now is many large truck engines become available in all the applicable sizes, 9-liter, 10-liter, 11-liter, 13-liter, and now 15-liter. You're also starting to see conversion systems for these large diesel engines, as opposed to having to put a new engine in these vehicles as they come from the factory. There's millions of trucks on the road which are already out there. And what can we do with those? Well, we're starting to get conversion systems that we can put on those that will convert them to either 100% CNG or a hybrid, where they use 15% CNG and 15% diesel and 85% CNG. The diesel component remains in order to achieve compression ignition on some of these motors, because that's the way they're built. So what we're really starting to see is, and what I think a lot of folks, especially in the natural gas and drilling businesses, see, is that transportation is really where we could see a very large increase in the demand for natural gas relative to residential or industrial.
Can I ask a question on that?
Yeah.
Can you talk about the perception of the explosiveness of a natural gas tank in a vehicle compared to petrol?
Yeah, absolutely. So natural gas is a compressed gas, and it goes into a tank. The standard in the United States is at 3,600 psi, which is a lot of pressure to be confined in a vessel. The vessels which we use today are a combination of carbon and Kevlar woven composite products that contain the gas in a manner that is actually very safe. And a lot of people need to get that and understand that message. Those products are extremely expensive. The largest cost driver in a natural gas conversion today remains the tanks. And the reason why it's the most expensive is because there's an awful lot of engineering and testing that goes into those vessels to make them safe. Some quick anecdotes about that are that there's really only 3 or 4 composite tank manufacturers in the United States. Presently, there are no composite tank manufacturers from outside the United States that are able to sell tanks in the U.S. market, so they're entirely domestically produced. Those companies have to pass certain tests before those cylinders can ever be placed into a vehicle. And those tests include on-fire testing in an incinerator. They include crash testing. They include dropping the tanks from high distances. They include things like shooting a rifle cartridge at the tank in order to see how it fails. They're designed to fail in a very inert manner, and there's a series of pressure relief devices and electronic valves that all these tanks are fitted with to make certain that they're safe. Our vehicles, the vehicles that my company has produced, we've got over 50 instances of collisions at this point. And in every single one of those instances, all the systems have done exactly what they were designed to do, which is to have the pressure relief device activate if applicable, and everything is